Today we'll be looking at DTM simulating 9 IEDs from the UCA IOP demo in New Orleans. This workspace simulates a small substation and helps show exactly how DTM can be used to simulate, display, and organize data from a substation. Today we'll be looking at 3 parts of this simulation: the single line diagram, the signal flow diagram, and the GOOSE Event Viewer. All of the devices are simulated in the workspace tree area of DTM. The device behavior is simulated by JavaScript, which we've put beneath it. We've pulled out all of the parts we are most interested in and created a diagram to help convey their behavior. The display shows 2 line bays and 2 transformer bays, each with a protection relay and a bay controller. The buttons across the top show ways that we can create faults on the line. When a fault is created, the breaker will open and try to clear the fault. Then the reclosing function will close the breaker again. The breaker was green when it was opened. The reclosing function then caused it to close again. The toggle switches next to the buttons will convey whether the fault is cleared by opening the breaker or if it is a permanent fault. As you can see, the fault is permanent and the breaker will reopen after closing until the fault is cleared. There are 2 buttons next to each breaker. The first button will determine if the breaker fails to open during the initial trip, while the second one determines if the retrip signal also fails. If it does, this will cause a breaker failure event. GOOSE messages will be sent in the event of a breaker failure to the other breakers in the network. This will allow them to open and stop current flow. This is our signal flow diagram. Its purpose is to show the flow of messages between logical nodes. It also allows you to quickly see which logical nodes are publishing GOOSE and who's subscribed to them. This display was created by sorting the data from the entire workspace, seen here. Now to recreate this, you can go to the substation folder, right-click, Show Data Points. This brings up a pane with all of the data points in the entire workspace. You can filter or sort this, but we also have a view you can select, the GOOSE Table View. This has filtered out all information that is not GOOSE related, grouped it by the publisher and the path. We use this pane to develop our signal flow diagram, specifically line 1 PR and line 1 BC. Now that we have this diagram set up, let's see it in action. I'm going to cause a fault that will result in a breaker failure event like we did before. This time, however, we'll pay attention to the signal flow diagram. You can see that the lines have changed to a red color when there has been data that transferred between logical nodes. For a full history of what has happened, you can mouse over the line. You can return to the original state at any time by clicking Clear History. The last thing we'll be looking at today is the GOOSE Event Viewer. This is the section where any GOOSE messages received are recorded. For this example, we've grouped by time and GOOSE ID. This allows us to see when the GOOSE message was sent and what it is containing. Let's go ahead and trigger the breaker failure that we did earlier. As you can see in the GOOSE Event Viewer, all the GOOSE messages are logged and recorded. DTM was used to simulate the protection and automation functions for this substation. The IEC 61850 model from the SCD file was used to simulate the IEDs in this substation. Real GOOSE messages were published in this simulation, so that it could be adapted to test real IEDs or other devices like HMIs, RTUs, or PLCs. We can see these real GOOSE messages using Test Suite Pro, another one of our test tools. In another video, I'll be going over how to monitor the GOOSE message streams and visualize the events created by this substation. When published, there will be a link to that video at the end of this one. Different diagrams and views can be configured based on your project needs, like the one seen here today. Please contact us if you'd like this example DTM workspace, Or let us know if there are other tests you'd like to automate with DTM using a similar approach. Check out our website or email us. Information's in the description below. Thank you.